Ladies and gentlemen, we will start momentarily. Please move to your seats. Ladies and gentlemen, please take your seats. The session is beginning to start. Ladies and gentlemen, please welcome to the stage Jennifer Swanson, Deputy Assistant Secretary of the Army for Data, Engineering, and Software.
All right, good afternoon, everybody. So, yeah, excited to be here. Do we have my charts up? I think we're working on getting charts up. Okay, so I'm going to be leading a great panel today. We're talking really about the importance of MOSA and digital engineering and all of the design work that we're doing. So if we could go to the next chart, that would be great. So MOSA, you guys actually saw this chart this morning. This is the same chart that Mr. Bang talked about. I'm going to expand a little bit on what we're doing and how we're thinking about it. So we've talked a lot about open architectures, and really I think there's two main benefits to open architectures. One is for the government and the other one's for industry. So for the government, we need the ability to be able to plug and play solutions. We have not been good at that, right? So we end up kind of getting vendor locked with a vendor, and that really doesn't benefit our customer, who is the soldier. So at the end of the day, what we want to be able to do, what we have to be able to do, is pivot, bring in new solutions available from anybody that are going to make the product better for the soldier. And the only way we can really do that is with an open architecture approach. And so for us, that's really the importance of MOSA. For industry, it's competition, right? Because when we're vendor locked, that doesn't help you guys either, because that means you really don't have a bite at the apple, because it becomes very difficult for the government to move off of whatever that vendor is. And so nobody else can really play in that space, and that's not beneficial to industry either. So to me, I think MOSA is a win for both of us. MOSA, to me, is a very loaded term because it means different things to different people depending on what your requirement is. And I think that's really what you're going to hear from us today up in the panel is we have MOSA for data. That data layer is critical, and that data layer is how we're going to be able to interoperate really across all of our systems. And for us, the UDRA is that MOSA for data. It's going to level the playing field. It's going to have everybody producing data products that are conformant with the UDRA so that they can easily be exchanged. And if you think about, if you kind of take it a few steps forward, it really is going to allow us to evolve quickly from this point-to-point architecture that we have. If you look at how we communicate with our systems today, it's all point-to-point connections. It's messaging standards that are very antiquated. I'm not saying we don't need messaging standards in the future. I think we will in some cases, but that shouldn't be like the default means of communication. So UDRA as MOSA for data means we're all creating data products, and I should be able to just go get the data product that I need to be able to get the information that I need. And that's kind of what MOSAizes it, if you will. From a software perspective, it's really APIs, which we listed a couple. Hydra is one that IEWNS has developed, and you're going to hear about it from Christine Moulton a little bit later on the panel. But generally speaking, open APIs. We don't want APIs that are tightly coupled to a platform. That's not open. So if I need this platform to use the API, that kind of defeats the purpose. But what we do want are open APIs that we're able to use and, again, plug and play different things at different times. The other piece of MOSA for software is the modern software framework that we're developing. We've released parts of it. Basically, it's really a methodology of how do you create reference architectures and reference implementations for your product. What are the things that we need to provide as standards out to industry to be able to develop into? And then what are the things that you guys own that we don't need to worry about? And really what we're trying to get after is industry is going to invest in capabilities. We're not saying we want all of the IP. Right? We're okay with black boxes to an extent. We want to be able to replace those black boxes as better black boxes are available, but we understand that you guys are investing your money and we're not after that. And so I think the concept of the reference architectures, reference implementations coupled with APIs is what helps us to get to that point. And then of course we have most of our hardware. So, we're going to hear more about CMFF today on the panel. Lots of different MOSA for hardware standards that are available, again, depending on what is my need. What do I actually need to do? So I think when you take all of those three things together, the Army is very much trying to go after open architectures for all of the things, digital, hardware, everything. Next chart. Okay, so digital engineering real quick. So I'm just going to do like a stage setter here, and then we'll call the panel up and you can hear about what the PEOs are doing. So we worked on this digital engineering directive with the UNDER for about, 6 or 7 months ahead of when it got signed. He signed it in May of 2024. And really what it does is set the stage for the Army to establish a foundation for real digital engineering adoption across. We are in charge of executing it on behalf of the UNDER, and we've pulled together an IPT from really across the Army. We've got AFC, we've got AMC, we've got ATEC, we've got ASAL, obviously. We have IE&E, we have a few other big players, Corps of Engineers, and everybody's really bringing to the table the things that they have so we can leverage what has already been done across the Army, and then we're assigning OPRs to fill the gaps, and that's how we're approaching it so that we're able to get the maximum output from this IPT. So I'm going to talk about the tenets, that really there's 4 tenets in this directive, and I will say the UNDER was very, very involved in the development of this. It's not, trust me, we did not just put a document in front of him that he signed. He was very involved in the content and in making the changes that he wanted to make sure that it really reflected his intent for the Army. So The first one is establishing these digital engineering focus areas. So we picked three: ground, aviation, and sensors. And the concept is really these focus areas are groups of people and probably digital engineering environments that are able to help each of these communities adopt and implement digital engineering faster. And the reason we're dividing it by community is because digital engineering for a vehicle is different than digital engineering for an airplane, is different than how do I pull all my sensors together and what are the things that I have to do. And so the under really wanted to make sure that we had, the right focus areas and the right communities to help everybody adopt. So this is something that we are working right now. I'm not ready to say exactly who is doing what, but what I would tell you is I think ground and aviation, there is already established communities within AFC that are doing a lot of this work within DevCon. And so it probably makes sense for ground and aviation to anoint those groups as the ground and aviation DE focus area folks. For sensors, there's not. And so for sensors, we're working through, is it DevCom, is it ASALT, is it a combination? So we're gonna figure that out and let you know as soon as we know. But that's what this tenet is about. Next chart. Okay, so interoperability and implementation is about a number of things. Number one, we need interoperability between digital engineering tools. We don't have it today. That's a huge, huge problem. It's a very big impediment. If there's digital engineering tool vendors in here, which I'm sure there are, and you guys have heard me say this before, SysML 2.0 is really the path for interoperability, but the devil's always in the details when you're implementing a standard. And so I think it's really, really important that we have all the vendors aligned in terms of implementation of that standard so that we are able to share data across, because what's happening today is we will have sorry, I keep touching my mic. We will have an environment or 5 environments, right? We have PMs that are doing what they're doing. They're setting up environments with different tools. Their vendors are going to have environments. Their suppliers are going to have environments, and we're not all going to buy the same tool. That is never going to happen. And so without the ability to cleanly share data, the entire community is impeded in terms of real implementation. So I think we're on a good path. Digital engineering tool vendors have said that they are implementing and that they plan to get there very soon, like this year, so I'm very hopeful. But I just want to foot stomp that is critical to really being able to implement this vision. And then some of the other things that we're doing here are we're collecting a lot of contract language that some of our pathfinders have used. We're refining some of it. We're putting playbooks together and different things to really guide the Army on, how do I build requirements this way? How do I develop this way? How do I design this way? How do I test this way, et cetera. Next chart. So pathfinders. So one of the tenets is really just about the pathfinders. We selected pathfinders that are different phases of their life cycle. So we have some very big ACAT 1 early stage programs that are going to help us really learn how do we do the requirements piece and transition that to design and development. We have some pathfinders that are later stage, and we have some smaller ones, and we have some software ones. And the idea of that was really let's get as much information as we can from these pathfinders so that we're able to capture those lessons learned. And one of the things that we did with the software directive is we used pathfinders to identify what are the obstacles that the Army can fix. Like what regs, what policies, what things do I have to change? What processes do I have to change to make this software directive work? We're doing the same thing for digital engineering with these pathfinders. Because there are regs out there, for example, that say literally you have to test on a hardware prototype. But do I? I don't know. sometimes, but probably not all the time. So we're looking for those obstacles and definitely for feedback from industry, because I'm sure you guys know that there are probably things that you have identified that, hey, if we can only just do this smarter or do that smarter. So the more feedback you provide us, the better, because the more we can action to go, make that change. Next chart. Okay, and then the last one is really, I will say, best for last, people. I think digital engineering is probably the technology with the highest bar to entry that we're talking about in the digital transformation space. Most people, all of us, are used to reading documents, reading Word, reading PDF, looking at PowerPoint, like that's how our brains process information, because that's what we know. Reading a model is a skill that you have to develop. It's not something that you just innately understand. And so being able to really level up our workforce to understand how to read these models, how to interpret these models, how to then take the next steps and apply my engineering knowledge within a model to understand, is the OEM doing the right thing? Is there a better way to design this? It's going to take a little bit of time, and it's going to take a little bit of effort. And so we're curating training that the Pathfinders have used. We're pulling together training that industry has provided us in terms of, hey, there's free stuff out there that you could use. And we're leveraging these pay-to-play, that's my term, pay-to-play digital engineering environments that are out there where you can basically go and rent time to try to make sure people have some hands-on time on the tools and reading the models, et cetera, as well. But I think once we get to this, it's really going to be kind of magic, because there's a lot of power that digital engineering brings to the table, provided that our workforce understands it and we have the foundation laid. So with that, I'm going to invite my panel up, if you guys would join me up here on the stage, and we will kick off the panel. Thank you. Thank you. Yep. Thank you. Okay. All right. Well, welcome, panel. So we can start down there and just go down this way. If you would each introduce yourselves and just talk a little bit about why you're on this panel.
Hi, Matt Paserno. Is the mic on? Matt Paserno. I work as the cybersecurity cyber director lead within the office of the DASA DES. I'm on this panel because Ms. Swanson voluntold me.
That's not a good answer, Matt.
I am happy to be here and share the stage with her.
Matt's on this panel because cybersecurity for digital engineering is critical, and it's a big gap, I will say. And so Matt's doing a lot of work that he'll talk about in terms of how do we secure data? How do we make sure that the keys to the kingdom aren't going to get hacked by China and they're going to have all of our design info? That's why Matt's on the panel.
And that's why Ms. Swanson said that. Thank you. So no, absolutely, that's it. We're looking at things from a MOSA standpoint as well as programs are transitioning to MOSA implementation. How we do cybersecurity of that in a more modular architecture, particularly for continuous monitoring or things like that, moving to more standards-based so that we can look at the best of breed across those weapon systems. And as Ms. Swanson said, absolutely on the digital engineering side, not only is it tremendous benefit for us, tremendous opportunities for our adversaries. So we want to make sure that we keep the crown jewels safe. Thank you.
Yep, thank you.
Bill Myers, PEOC3T, part of the Unified Network. We develop communication systems, radios, command and control systems. I'm here because I am head of the systems engineering team up at the headquarters level. So part of the digital transformation and the MOSA initiative. So right now we do have some modeling efforts going on throughout each of the PMs, but I'd like to say we're in our infancy too, because we still have yet to set up an environment, still trying to identify the training needs of our workforce. So lot to forge on.
So I'm Christine Moulton. I'm the Strategic Integration Manager for PEO IWNS Integration Directorate. For General Barker, I sit up at the headquarters level, really looking at the interoperability across PEO IWNS's portfolio and how do we better implement MOSA, how do we better implement APIs and standards across our programs so that we have commonality and shared interfaces. How do we work our dependencies on other systems data and other information, as well as combining all of that into the digital engineering ecosystem that we're piloting within the PEO, really looking at tying together not only our requirements, our models, but then also being able to use that to understand the architecture and really the information and the data exchange that we need to do in order for our systems to be effective.
All right, I'm Douglas Burby. I'm underneath PEO C3T, underneath PM Mission Command. I'm the product manager for Secure Signals Infrastructure, which is a portfolio program. One of our largest efforts we have going on right now is the CMOS mounted form factor chassis. So a lot of you have heard of CMFF. Some of you are proposing on that right now, so we won't talk about program specifics inside of there. But I will be talking about really Ms. Swanson's chart where she laid out the pillars of the different standards inside of there, because at my point for the chassis itself, for the CMOS compliant, so we've gone MOSA, SOSA, MORA, Victory, ACE, FACE, name a standard inside of there. I now have the program office that must comply to all of them. And there's a lot of benefits inside of there. One, all of those standards are a partnership between government, industry, academia, so you're familiar with them. So there's a lot less exploratory knowledge that goes on between each of us as we're discussing these, and we can kind of lay that out as we go. But I'll be on the execution piece from integrating the standards-based software, integrating the bent metal components with those appropriate standards with our industry partners inside of there starting next year. All of you have been working on the prototypes now based off of those standards. And when we get back, I'll talk a little bit more about how we've used those standards in your prototypes to help kind of shape our direction.
All right, awesome, thank you. So, going back to what I talked about earlier, I think what you guys are gonna see, and I don't wanna pigeonhole our panelists here, but I think Christine is very much in the MOSA for software, for data, and digital engineering space. And so I think what you're gonna hear her talk about really brings those three things together. I think Doug is in the MOSA for hardware space primarily, which is very, very important. I think Bill is more in the digital engineering space and modeling, and you're gonna hear more about that from him. And then Matt really does cross over all of those things, but I think Matt's focus up here today is primarily cybersecurity for digital engineering and data security, right? And data security obviously can apply to a lot of things besides digital engineering, but it really is critical for digital engineering in particular. So with that, I'm gonna start with Christine. So Christine, you are, IWNS and really you in particular, are leading a lot of fantastic work with the sensors architecture work that you guys are doing. You've really moved quickly there, that really, like I said, you're integrating APIs. You showed us the UDRA component of that, which was very impressive. And you also are moving very quickly in the digital engineering space, and there's a tie there. So can you talk about all that stuff?
Yeah, definitely. So, just to start on the first piece as far as the interoperability and how we're working MOSA and UDRA, we really have efforts within the PEO, one being the integrated sensor architecture, really being a standard and an API that we are using to help with our sensors being able to speak a common language and be able to interoperate seamlessly with all the platforms. Within PEO IWNS, we're a very diverse portfolio as far as the type of sensors and capabilities we create. Most of our programs, we have our own platforms that they will run on, but we also run on other program offices platforms as well. And so having the ability to have, the integrated sensor architecture, the Hydra API, being able to have a common interface that there's one way to get information and data and request the information. We're working very closely with PEO C3T as well to really pull together and have our common sensor APIs that we're pulling and creating within PEO be common across the mission command platforms as well. So we have a seamless interface between what our sensor data is pulling into the platforms, but then also what our intel capabilities can also pull down into the environments, and working together to be able to pull those pieces and really identify, what are the critical pieces of information that we need to share from our sensors to other PEOs. Also doing the similar work with our ABCANS partners and working also with, our foreign partners, being able to provide them common APIs to request information and data from our systems, of course, when it's appropriate and authorized. And then we're really pulling all of that information together. So we have our common APIs. We're working to understand the MOSA, where in our systems is that black box principle of, where does the information really need to be commonized in the common APIs that we're producing, and where does it make sense to have, the vendors, perform more of their capabilities within those black boxes. And pulling that all into the digital engineering, I would say we know where we want to get to as far as the full digital engineering ecosystem. But what we're really working towards now is understanding our architectures, being able to pull in all of the documents and pieces that we create for our programs, and really understanding where do they live, what is their security boundaries, what information do they need to exchange internally with the PEO, but then also externally to joint partners and others as well. So being able to tie in where we understand the requirements to a model, and then being able to see where there's commonalities within those models. One of the things that we're finding is that we will have requirements and not have a reciprocal requirement on the other side. And so really being able to use the digital engineering to see, concerns or possible issues with our interoperability and the data exchanges before we even get down to full testing, and be able to pull in pieces and test incrementally in a smaller fashion to really help us understand how our data is going to be shared and exchanged as well. And all of our common APIs with Hydra, with the integrated sensor architecture, are moving towards that. And then even as we move towards TAC and TAC-X interfaces and those pieces as well, having the common API backbone really allows us the flexibility to adapt, as new capabilities come out.
Yeah, thank you. I want to pull the thread on two things, or just comment on two things that you said. One, with regard to what you guys are finding with DE, where you're able to find things quicker, test faster, potentially test, less, because you're able to get ahead of things. That's very aligned with what our XM30 and Flora Pathfinders are finding as they evolve their digital engineering capabilities for their programs. And I said before, digital engineering is a very high bar to entry, and it does, because it's hard. It's hard. I mean, it's just hard. However, the benefit is humongous, and so I think it's definitely the right path for us. It's just going to take a little bit of time for everybody to get there, but you guys are doing really well with that. The other thing that I wanted to say is it's exciting that you're getting such interest on your sensors architecture, especially from the joint and NATO world, because I think that's one of the areas where, when we think about UDRA, it's hard to think about a time when maybe we're not messaging everybody everything, just because that is how those communities operate right now. But I think you're breaking some real ground there with those communities. It's really going to help set the foundation for us to evolve much quicker. So thank you. All right. So Bill, over to you. So, you know, I spent some time at POC3T in my career. And, you know, what's funny is that honestly, a lot of things change, but a lot of things stay the same. And I think the network is, was, and always will be a difficult nut to crack because a lot of it is bought commercially. Making all of those things work together and interoperate is challenging. It's never really enough, right? We are not gonna have enough bandwidth in the tactical environment ever, and that's somewhat physics and other things, but it's just always a challenge. How is C3T using digital engineering capabilities to try to do modeling and try to get after some of that?
Yeah, so what you're saying is, you know, everything touches the network, right? So we're the unified network. So it's important not just to have that system interoperability, but also have that model interoperability. And the complexity of the network is never to be underestimated. You know, the network evolves so much quicker than we are being able to model. So it really takes a village to come together and do that modeling work. And we have a good relationship with each of the POs across the Army. And I think just coming on a single standard for all our modeling work. But we have tried to model a network and through one of our USARCs and just trying to get in some of the network bases of issue. That's a huge challenge. Whole reason you're really going to a unified network, right? Because the amount of networks that the Army tries to manage today is just, you know, it's just boggling. So when we can execute a unified network, I imagine that the modeling piece would be much easier, but we're not there yet. But we're really, like I said, we're just really trying to leverage what the other POs with their modeling to help feed into a holistic, comprehensive model.
Okay, thanks, Bill. So Matt, over to you. So data, digital engineering, cybersecurity, what are your thoughts on all that?
I think when we first got involved with this, working with some of the PEOs, they described what you described as, you know, traditionally we had been looking at PDFs or we'd been looking at individual files, so we kind of lived in a world of security by obscurity. And as we make the data more visible and more useful, we have to be very deliberate in our protection of it. We joked before, but there are absolutely adversaries out there that would love our critical modernization data, so we need to protect that. So our approach has been threefold. The first is really understanding the threat, so working with the intelligence community to understand not only threats to our environments, but also weaknesses within them, and then certainly communicating that across the PEOs as quickly and effectively as we can to make them aware of specifics, but also just ensuring the culture of security throughout digital engineering modernization. Number two, we have a policy that is currently in GOSES staffing. We had a previous version out on sam.gov for industry feedback, but we're looking at making digital engineering data, meaning our models, the artifacts from that, and some of the other threads as CUI. And we're taking that as a deliberate approach because rather than try to mandate how we protect that across all of our environments, simply taking that data approach that is critical, it should be controlled. We'll let various components of the environments figure out how best to meet those requirements. So that's currently out there, and happy to take feedback or follow up after, because we absolutely would love feedback from the group. And then number three is, I kind of referred to the digital engineering environment, implying that it's a environment. And I think it's a pretty diverse ecosystem with cloud and on-prem capabilities spanning industry and academia, the programs, even within the DoDIN, a number of different players from AMC, the program offices, the capability developers. So we're starting right now, we're kicking off probably a series of pilots where we're looking at best practices and data protection solutions that we can not only protect the data, but like you said, ma'am, ensure it's interoperable and we're not locking ourselves out. And I think that's going to be a challenge, just again, given the diversity, but one that we are going to take head on and certainly work with the community to learn as we go.
Yep. Yeah, and just to kind of double down on what Matt said, so the policies that we're developing are founded in work that Matt's team is doing, Matt and his team are doing to really vet with industry, but also vet in some pilots. For example, for data security solutions, what are the things that we would want to require in a data solution and a policy? We're not going to say use this tool or use that tool. We're never going to do that. But we do want some of the key capabilities that are out there in different data security solutions. And as we develop that, and same for the policy that you talked about where we're treating everything CUI, which is better than what we have today, which is frankly nothing. That's going to apply to all environments. So whether it's a government-owned environment or an industry-owned contractor-operated and owned environment that is doing work for us, the bar is going to be the same. So it is important when we put out these RFIs that you guys give us that feedback, because it's definitely going to affect you. But at the end of the day, we got to be able to secure the data. And so we want to make sure that we're putting out executable policy. But I would say not putting anything out is not an option in my view.
And just to triple down, ma'am, we absolutely take that feedback seriously.
Yep, absolutely.
And we absolutely, we factor that in as we go. So I think, even like you said, I think we're taking a MOSA type approach to how we secure that data across a diverse environment.
Yep. All right, thanks, Matt. All right, Doug, so MOSA for hardware. So do you know anything about that?
Yes, just a little bit. So MOSA for hardware. So we're in the unique situation now of everything everyone's talked about is my program office is postured to benefit from everybody's hard work. And that's one of the keys. That's one of the reasons why the modular architecture works for us. So we have several different architecture standards that we have to deal with at the point where I'm taking communications products, which are comms-based, versus aviation or face-based products, victory standards for integration with ground combat systems. I have to utilize, the digital engineering aspects, particularly the aviation side of the house, because not only am I looking at how am I going to integrate today with size, weight, power constraints, victory compliance, save space with software that is either SOSA aligned for management of tools, which CMOS for waveform configurations inside of there. What the standards actually allow us to do is talk to you better, talk to our customers better. It saves us time, energy, space, and one of the big things that we have noticed, even before we've started bending metal on vehicles to comply with new chassis, is non-recurring engineering, costs and expenses. So the NRE, the trial and error, leveraging digital engineering when we do the engineering aspects based on our CMOS compliance for what I'm putting into a chassis, and then I'm using Mora or Victory or FACE standards to put it onto a platform. Whatever I'm doing with one platform, the other platforms can see. Whatever standards that has to be adjusted, either based on industry, academia, or government inputs, is done by all and known by all. So some of the direct results that we see right now, so when we get RFIs, as we were putting out our RFIs to industry, we were getting answers back that said, are you referring to standard or reference architecture dated on this date or on this date? Because we heard Ms. Swanson or someone else at a speak say we were going to adjust a standard. That tells us we're already speaking the same language, because now we're quibbling over version 1.1.1 or 1.1.2, in which is in draft form, because you guys want to know if I'm executing, I'm probably going to execute to what you're currently working in a draft, but the entire community knows that standard. So that is helpful not only to ourselves, but our other agencies. Like I said, if I can prevent any non-recurring engineering a year from now, that saves the taxpayer tens of millions of dollars down the road. If I need to adjust an aircraft that is not even going to be into a bent metal phase 3 years from now, but I can do it with digital engineering today, that saves us years of development. And it also benefits everyone else. So when I'm building a chassis, and I'm integrated into FLRAA, into AMP-V, to XM30, or any new platform coming in, I have to adhere to the same standard across the board by all, because other agencies and other activities and other software developers are still adhering to that. I get to benefit from everyone else's really hard work, because if you can't comply, it doesn't apply to the system, but everyone knows that ahead of time and knows that now. So it's a win-win for me. It's a win-win for you on the taxpayer side of the house, because we're not bending as much metal arbitrarily. We're not bending as many cables arbitrarily. We're not cutting so much code that doesn't execute or pass the certification level, and we know that to begin with at the very get-go. So we're excited about standards. We're very much standard cheerleaders in the program, because it saves us tons of work, and we can always cite a reference. You know, our reference architecture can cite a standard. Instead of us typing 200 pages of standards, we can refer to somebody else's homework, and I'm all about using everybody else's homework. So with that, ma'am.
All right, Doug, thanks. Yeah, I mean, I remember the history of, you know, CMOS, now CMFF. It goes back to when I was at POC3T, which is now, feels like a long time ago. But that was really, I think, an example of a very good transition from S&T to PM, right? Because it started in the S&T world, and actually my deputy, Tom Brutowski, so some of you may know, was very actively pushing it within the PEO community and trying to make sure that, you know, it had a transition home because of the benefit. And now we're seeing that benefit with CMFF, where, you know, we used to have 1 million different connectors and 1 million different boxes, and now, and 1 million different cables, right? And it's not good for the soldier at the end of the day. So all of that streamlining, like you said, you're benefiting from all of that. But I think really the one benefiting from it is the soldier, who doesn't have to have that, you know, all that mess in his vehicles or her vehicles. So, okay. We are going to transition to questions, but first I do have a public service announcement. So Digital City is something that you may have heard Mr. Bang mention from time to time, or you may have heard RJ Mikish mention from time to time. So Digital City is an initiative that really Mr. Bang is leading to stand up an open collaboration space in the DC area for companies and government. So you can look at it as, you know, a place to innovate, a place to integrate, a place to be able to determine what do we need, what does industry have to bring to the table, and, you know, how do we put all of those things together. Ideally, it can help to potentially focus some of industry IR&D dollars on capabilities that the government is looking for in a lab kind of environment that, you know, there's things we miss when we don't have that. So there's things that we know we need, there's requirements that we have, but it really is, I think, that hands-on capability that Digital City will bring to the table that will enable us to really identify more gaps. So I don't know if RJ is in here anymore. I saw him before, but I think he walked out. So RJ Mikish is the guy that I congratulated before on being our newest BG, and now he has a lot of work. So he is the guy that is leading up this Digital City initiative for Mr. Bang. So really, this is for you guys to be aware of that, and if it's something that you are interested in participating in, please reach out to General Mikish, and he's really interested in talking to industry, getting your feedback, and getting this set up as quickly as possible. Okay, so now I think we can transition to questions.
The first question is there an intent to focus this at joint, and how would it evolve to service implementation? And part two is there a vignette to bring this discussion together?
Focus, what is this?
I believe it's referencing the adoption of open standards and digital engineering practices.
Okay. I mean, I think there is certainly an effort to do this at the joint level. There is congressional language that dates back several NDAs, if not more, that talks about the importance of MOSA. There's probably initiatives that, like Christine, you might be able to talk more about specifics with joint community and other community partners. I think we're looking at it certainly from a service perspective, but also if there's anything you can add to from a joint perspective.
Yeah, definitely. So a lot of the work we're doing with our standards APIs applies to the joint systems as well. You know, from a macro level, similar concepts of what we're trying to do. And so we're actually working very closely with the Navy, the Marine Corps. We're also working with a lot of our Intel partners to come together and commonize those pieces. And what you'll see is as the Army is executing more of these joint experimentation events, there's going to be much more emphasis on actually using our standards to share the information and data and starting to test out and show the interoperability between our joint systems at those venues and in those exercises. And so I think as we move forward, there's going to be a lot more demonstrations of capability where we have our Army sensors, our Navy sensors, and then Air Force and also some of our Intel friends all sharing information in the common APIs and formats. A lot of the work that we're doing with the joint community is looking at the standards they're using, the standards we're using, and aligning the architectures. So at the fundamental engineering level, we're aligning the architectures so that we have a seamless switch between the common standards and interfaces. So as far as our operators and our soldiers are concerned, the information is flowing, but behind the scenes is where we're doing the work of aligning the architectures. I think that as we move forward with our interoperability and the digital engineering, we're going to start commonizing on common architectures, common reference implementations that we are going to align together as far as government goes, as far as the black boxes and those pieces to enable this interoperability. So I think as we move forward, especially with the exercises coming up, and there's going to be a lot more demonstration of that.
Yeah, I think what you guys are doing is a great example of how that can be made to work. Because I think, generally speaking, doing things just within the Army is hard, right? We're big and it's hard and there's a lot. Doing things in a joint community is harder because every service has their own requirements, their own way of doing things, their own money, and so you just kind of add level of complexity. And then when you include, you know, foreign, NATO, all of that, it's like really, really hard. But you guys have done it with the ISA, and so I think it's a great model for others to follow.
And ma'am, just to look at that from a protection angle as well, our approach is joint. We're working very closely with the Air Force. We're sharing supply chain risk management assessments. We're looking at how their centralized approaches through cloud technologies and how they're protecting those there. And we want to share best practices, especially as the data that is going to the industry side or industry is supporting multiple services, they're going to have to, kind of address multiple different types of policies. So we're trying to synchronize the policy as well. But I think, especially in this area, as you mentioned, like we have to change, and my guidance is to move fast and fix ASAult first, right? And so we have to protect our data.
Yep, makes sense. All right, any other questions?
For the digital engineering footprint, outside of black boxes, are we looking to standardize containerization and scalable Kubernetes for the MOSA shared application APIs? And will CSPs assist with the infrastructure for future digital frameworks?
So I think we certainly want to standardize, but I also think that we don't want to go too far and limit flexibility for our application developers and our PMs. And so I think we have to draw the line there, because if we go too far with those standards, we will really force people into specific patterns and implementations that aren't what they need. So I think we're trying to walk the line. We want to enable plug and play. Like I said, we want those open APIs. We want reference architectures that provide guidance and guidelines, but not necessarily really, really hard lines, because then I think we somewhat limit, like I said, ourselves from doing the things that we need to do and or maybe don't know that we need to do right now, but figure it out as we go. Anybody want to add to that?
I think one of the things that we found as we've started on our digital engineering journey, especially within PEO IWNS, is it's, like Ms. Swanson was saying, it's a fine line to walk. But the other thing that we need to keep in mind is we do have our legacy systems that we are still needing to interoperate with and work with as we move forward. And so really bringing them into, modernizing them to the point that makes sense for their position in their life cycle, but getting them into the digital engineering as well. And being able to bring along those legacy systems as we phase them out with the new programs as well.
Yeah. Yeah, I mean, that is a really, really great point, and that is something that we have outside of IWNS. We have it everywhere, and I think we will always have, is we want to modernize, and we're doing a great job, I think, of really accelerating that modernization, but we do still need backwards interoperability with the stuff that's out there, and so building those bridges as we go is critical to being able to enable that. Any other questions?
You have a few, ma'am.
Okay.
Clear and unambiguous interface definition and properly documenting these interfaces is crucial to enabling third-party incremental upgrades. I'm putting you on the spot here. Where have you seen it done well, and where is there more work to be done?
So I think that I'll use Hydra as an example of where I think I've seen it done well. I think that the Intel community has done a very good job with that API in terms of walking that line that Christine talked about and I talked about earlier well. Because I think it is, it enables us to bring in third-party tools, applications, et cetera. It's extensible, it's flexible, so I think it does a really good job there. And in fact, my team and I are going to deep dive Hydra next week with the IWNS team to really try to model something for the greater community based on what they've done. Where I think there needs to be more work is everywhere else. So that's what we're trying to solve by leveraging the model that they have developed, because I'm all about, like, if something works, let's try to leverage that and not reinvent the wheel. Anybody have anything else to add to that?
I will say we at the last time in Philadelphia, Colonel Day on the PM for Mission Command put out a request to industry to show an example of that interoperability between various vendors with the CMOS standard for the communications equipment. And he said it very simply. He says, I'd like somebody to come in and put on a desk your chassis, your competitor's chassis, a bucket full of cards from all non-associated vendors. So now we've got some CMOS, we've got some SOSA in there, we got some Victory inside of there, and it says, I want you to load up your chassis randomly, I want you to fire it up, show everything that's working, then you're going to shut it down, and we're going to put our hands into it. We're going to take a couple of those cards, we're going to shove them into somebody else's chassis. I'm going to take one of your cards, put it in somebody else's chassis, then I'm going to take some random one that I bought in the parking lot from somebody, and I'm going to put that into the chassis and fire it up. That was at the Philadelphia TIM, and probably about 2 months ago we showed that exact same demo from a partner of about 4 or 5 different vendors to show us that we can make all of our stuff work together just using a singular standard. And they did that, and it was CMOS compliant. We were very thankful for that, because that allows us to come back to Mr. Bang, Ms. Swanson, Mr. Bush, and our stakeholders and saying, we asked them to put up or shut up, essentially, is probably a little bit rude, but we said, you've been telling us you could do this. We asked you to show it to us. You showed it to us. Now the ball's in our court. And that's why we're taking this forward in 25, because you guys did that. You showed you could follow a standard without working with the counterpart directly and cross-level your work, and it worked just fine. It literally worked. With that entire demo, took less than 15 minutes. That would have been a 4-week pilot exercise if we were doing that under the legacy system. So the standards do work. I've seen them work. We're telling our senior leaders it works, and we're going to be showing the soldiers very shortly that it works in their kit.
That's awesome. That's very, very cool. Yep, thank you. All right, I think we probably have time for one more.
You mentioned that DE has the highest barrier to entry for many reasons, including skills needed. In what ways can industry who may have the experience or skills needed help to decrease some of those barriers?
Yeah, that's a great question. So I think tools, I would say curriculum, although, I think, again, going back to the focus areas, right? I think aviation, different than ground, different than sensors. So I think different industry partners in different areas can help us. If you have upskilled your workforce for one of those 3 priority focus areas, I am very interested in learning how you did it, what your curriculum looked like, how did you couple, I would say, classroom learning with hands-on learning. What types of tools are you using to do all of that? I do think that it is something, it's very different to look at models, like I said. And so, how are you getting your workforce to be able to think that way outside of just the curriculum? How do you get folks to apply the engineering knowledge that they have in a model-based world, not a paper world? So I think those things would be super helpful, and I'm very interested in anything that you guys have that can help us to do that. And I also think it goes beyond just the engineers, right? Because when this directive that the undersigned is Army-wide, it's not just for the engineering community. We really, ideally, ultimately want to get to where all of our Seadrills are digital. But in order to do that, we need to be able to get contracting folks and lawyers and budget people and logistics people and other folks to be able to really process those digitals, Seadrills. And so how are you doing that within industry? Because I would imagine it's a similar kind of effort there, that you don't want to have to convert all of those things to paper and hand them to the budget people so that they can figure out what they need to do. I think getting an understanding of how you're doing that would be super helpful. Anyone else?
Yeah, and that's what we're looking at, right? The path forward. We're not going to get there tomorrow, so we're going to have to lean heavily on industry building us those models. But we're taking a look right now, who needs to be trained with what curriculum, right? And I totally concur with what you're saying. We have been so focused on the engineers, but now we're looking at with the configuration managers and enabling business processes with those, the logisticians. How are we going to build that path that we have that hybrid? Right now we're heavily leveraging on industry, but eventually we're going to get to that organic type of workforce.
Yep. Yeah, and being able to scale that training. Obviously, not everybody needs the same thing, right? So what does that look like in your organization? So, all right, well, thank you very much to my panelists. You guys did a great job, and I think hopefully everybody got a good appreciation for how we are approaching DE and MOSA in the ASOL community. Thanks a lot for joining me up here. All right.
Thank you for joining us today. The next session in this room is a keynote presentation from Lieutenant General Robert Skinner at 3:30. There are also several other sessions in the meeting rooms and the Exhibit Hall Theater this afternoon. Please be sure to join us for this afternoon's networking happy hour in the Exhibit Hall, supported by Comcast Business. Thanks again to the audience. We'll see you back here shortly.